In this video, I'm going to show you time series analysis using Python. Generally, we have 3 steps to complete the time series data analysis. In the first step, I will talk about the data preparation. In the second step, I will show you the data visualization. And in the last step, we will run the autoregressive integrated moving average model to the time series data. I'm going to use a Jupyter Notebook to do the time series data analysis. In the first step, you need to load the libraries. First, you need to import NumPy, Pandas, datetime, XLR-Red, Matplotlib to the Jupyter Notebook and run it. In the next step, you need to load the data. Okay, I'm going to use unemployment rate seasonal adjusted data for the US, which can be downloaded from the Federal Reserve website. You need to download the CSV data, and the second data that I'm going to use it's for state of Oregon. You can download the CSV data for this time series data. I have already downloaded. This data, and you can download it also through the link under this video. I'm going to use a read Excel function in Pandas, and then also I need to refer the sheet name. And index column, I'm going to set as a date, and also I'm going to parse dates. Equals true. And we can see the data. Okay, data is loaded to the Jupyter Notebook. In the next step, I'm going to fill the null values for the state of Oregon. To fill the null values, I'm going to use the fillNA function. Okay, I'm going to fill the ORUR column equals data Oregon unemployment rate, and fill NA. I'm going to enter them as a 0, and then we can show the okay. I fill the state of Oregon null values as a 0. In the next step, I'm going to adjusting the data format. Okay, first I'm going to shift the string format to the datetime format. To this purpose, I'm going to use a datetime function. Dates equals PD date time and data date equals dates, and the other variables that I'm going to use it, data, I need to change this data format to equals as float 64 format, and then I'm going to use the same method for my other variable, other column. Okay, and we can show the data D types. Okay, there is here 2. Okay, now I have a data format, date time format for my date column, and other columns converted to the float format. I'm going to create a new columns, differences between the unemployment rate between the state of Oregon and United States. I'm going to create new variable, data. To create a new variable, I'm going to use a differ data minus data equals and then I can show the data. Okay, I created the new variable, and in the next step I'm going to customize the date because I don't have a data for this period, and I'm going to slice the consistent data between United States and state of Oregon. First, I need to recognize the exact date, data, date, I'm going to copy these columns and I'm going to use the ilog function, ilog between the index 333 to 340, and I need to use a double square brackets and then run it. Okay, you can see that the unemployment rate data for the state of Oregon starts from the 1976. So I'm going to slice this data since 1976 until 2020. So for this purpose, I'm going to customize the dates. Okay, my start date is 1976, January 1st, and then end date equals 2020 August 1st. And so I'm going to define as a period equals data bigger or equals start date and date smaller than the end date. I'm going to define it as a new data frame, df equals data dot. I'm going to use a look function and period. I'm going to display the data frame and okay. Now I extracted the data since 1976 until 2020, and I have all information for my 3 columns: unemployment rate for the United States, for a state of Oregon, and differences between the unemployment rate for US and Oregon. For example, I'm going to show you what is my values for a certain day. For this purpose, I'm going to use a log function, df point log, df date, for example 2010 January 1st. Okay. The unemployment rate for the US and Oregon is 9.8 and 10.9, and 1% difference between these two data. In the next step, I'm going to rename the columns label to make it readable. Rename columns equals, I'm going to use a dictionary function. I'm going to change date to date. I'm going to change your rate to US and Oregon to change it to the Oregon. And also I'm going to I'm going to define these rename columns to my data frame. df equals df rename equals columns, and then also I'm going to show the data. Okay, now we change the columns label to our desired label. In the next step, I'm going to show you how you can plot the time series data. To the plot, we need to use a plot df I'm going to define date as a x and US as a y. And also I can display the second variable too. I'm going to bring the Oregon. I need to use the double square brackets. Okay. I need to resize the graph size. PLT. I'm going to use a fixed size equals 18 to 8. Okay. Now I can run it again. Okay, now I can see the two time series data for United States and the state of Oregon as a line graph. But I need to add some information in this graph. So I'm going to use the same codes. First of all, I need to change the style. Use GGPLOT. Okay. Now I change the style and I'm going to add the labels. To add the label for the X label, I'm going to put date. And for the Y label, I'm going to use a unemployment, and also I'm going to put the title. Seasonally Okay, now I'm going to put the title seasonally adjusted unemployment rate in the US and the state of Oregon, and then run it. Okay, X is not defined. I need to define the X. I need to use a fig as a X equals. Okay, now I have a title and labels for the X axis and Y axis. And also in the next step, I can add some annotation to my graph. I'm going to add the 3 annotation on the graph. The first one is the state of Oregon high employment rate in the 1982, and the second one is the high unemployment rate in 2009, and the third annotation is the starting the COVID-19 pandemic in 2020. I'm going to add these 3 annotation on the graph. Okay, I can see the 3 annotation that added on the graph. And also I can add the legend. To the legend, I'm going to use a df double square brackets and I'm going to add these two to the legend. And okay, now I have a legend for our line graph. Also, I can display the different line graph too. In the next graph, I'm going to display the differences between the state of Oregon and US unemployment rate as a line graph. To the line graph, first I need to bring the size, plt command, plot df, okay, this is the differences unemployment rate between the state of Oregon and United States, and I can see that mostly unemployment rate in the state of Oregon are more than the average in the US, but in the just only during the 1990s we can see the below the average unemployment rate, and also we can see that trend in the after the 2016, however 2016 until now. In the next video I will show you how you can apply ARIMA method to the time series data analysis. Thank you for watching this video.